All right, people, big day today. This is it, the last lesson for the year 2019 to 2020. And boy, what a year it's been. All right, it's nice and easy today. Last lesson of the probability unit. It's on multiplying probabilities. It goes and it combines all of the stuff we have learned this week. So we got a little conditional probability. What happens is we're going to compare like doing multi-stage events or experiments when more than one thing happens. So probability, we're going to talk about ands, we're going to talk about or, we're going to talk about empirical probability, we're going to talk about theoretical probability, everything today. All right, so example 1. Real quick review from the last lesson. Given that the probability of event B occurs, given event A has occurred, that's your conditional probability formula. And if you remember at the end of the last lesson, we did manipulate a little bit. It was pretty cool. But just right here, if I wanted to just solve for probability of A and B, so I want this by itself, I'm going to go straight forward and I am going to multiply. So when I cross multiply, the probability of A and B is equal to the probability of B given A times the probability of A. Now, that's a little annoying, right? Because we manipulated this. We did a substitution. And we made the formula another test for independence. And remember, right? If you are independent, the probability of B given A would be equal to the probability of B. That would be true. So we want to know, how can you write this formula if they were independent? All right, so I am going to rewrite it. The probability of A and B is equal to, now I am going to take the probability of B, because they're equal, I'm going to substitute that in. So the probability of B is going in for this piece here times the probability of A. And that is your formula. So A and B, when you see the word and, okay, you're going to multiply, all right, when they're independent. All right, so here we go. We're going to put it into motion. All right, the rearrangement of the conditional probability formula, this guy here, gives us a useful tool for calculating the probability of events that occur in multi-stage experiments. All right, you will easily be able to do this using the formula connected by and, right? So we have an and here. All right, so letter A, right? We have this spinner, we're spinning. It's spun twice. So we spin it, we record the result, we spin it again. All right, are the outcomes of the two spins dependent or independent? All right, think about the probability you spin it the first time and you land on the number 2. Okay, the probability that that happens, there's 1 2 out of 8, which would be 1/8 would be that probability. All right, let's say the second time you spin it and you're looking to spin a 2 again. Nothing has changed. You are still 1 out of 8 elements. So this, because the probabilities don't change, means you are independent. Okay, so let's take a look. What is the probability in letter B that you will get an even on the first spin and a number greater than 5 on a second spin? All right, so the probability of an even and the number is greater than 5. All right, so that means, according to my rule, we're going to take the probability that it's even and we're going to multiply by the probability that it's a number greater than 5. All right, you ready? Probability that you are even, 2, 4, 6, 8. 4 out of 8 options are even. Number greater than 5. 6, 7, or 8 fits the bill. There's 3 elements out of 8. So the probability that that number is even and a number greater than 5 is going to be 12 out of 64. Okay, which sometimes they'll reduce it. You can reduce by, let's see, like a factor of 4. So 3 out of 16 would be the same. Or the decimal, up to you. You got to see what they're asking you. If they're asking you in terms of a decimal, then you got to change it. If they ask you in terms of a fraction and 12 out of 64 isn't there, then look for 3 out of 16. All right, letter C says, what's the probability that you will spin a prime number and a perfect square? Now, in either order. Okay. If you looked at B, we had even on the first spin and a number greater than 5 on the second spin. So they were very, like, specific. Now here, they just want to know what's the probability you spin a prime and a perfect square in either order. So you can do two things here. You can either spin a prime first and then a perfect square, or you can spin the perfect square first and then the prime. So this is going to be a little bit more complex. All right, so let's just do the math here. The probability that you land on a prime. All right, 2, 3, 5, 7. Those are your prime elements. So there are 4 out of 8 of those. Now, perfect squares out of the 8. All right, perfect square. Let's see. That's going to be a 1. And 2 squared is a 4. So there's only 2 that are perfect squares there, right? There's only 2 that give you a nice, when you square root it, an answer. The square root of 4 and the square root of 1. So let's see what we get. We get 8 out of 64 here. So that is, if you wanted to reduce it, 1/8. Okay, now in reverse order, what's the probability that you spin a perfect square first? Well, that's going to be 2 out of 8, and means multiplication, a prime number 4 out of 8. So yeah, the probabilities aren't going to change, but you have to take into account that it could be any order. So now what you do is you have to add those probabilities. 1/8 plus 1/8 is 2/8. Right? Am I still on there? Which 2/8 is really 1/4. So the probability that it's prime and a perfect square, now that probability is 1/4. So here's a little key, okay? When you see the words and, you're going to multiply, like we did here, prime and perfect square. When you see the words or, you're going to add. So the idea is the probability it's prime and perfect square, well, you can get the prime and the perfect square, right, in that order, or you can get the perfect square and the prime. So we had to figure out first the and then we had to add them together. So the probability answer was right here, 1/4. All right, so I know it's a little tricky, but you'll catch on. It's not that bad. Remember that and means multiplication, or means to add. All right, so now we have another example. It's a little bit more complicated, but the idea is still the same. A class consists of 12 girls and 8 boys. We're grabbing a group of 3, so we're picking one at a time, okay? If the students were picked at random, okay, what is the probability that they will all be boys? All right, so you want E sub 1 to be the event that the first picked was a boy. Then E2 was the second picked was a boy. And the third event was that the third picked was a boy. So what you wanted in terms of that was, you wanted the probability of the first event happening and the second event happening and the third event happening. Okay, so think about it this way. The probability of the first time happening, the second time happening, and the third time happening. You see the word and, you're going to multiply. All right, now what happens is that this has without replacement. Okay, so just the numbers of the probabilities, you have to be careful here. So the first event was picked was a boy. If you look, we have 12 girls and 8 boys. So the part that is a boy would be 8 out of the total in the class, 20. Now, we've already picked one boy. So not only do we have one less boy, but we have one less person to pick from. So your probability for the second event is going to change, okay? So we have how many boys left? We picked one, we have 7, but now there's only 19 to pick from. And with the third event being a boy, we have one less boy to pick from, so that's a 6, out of one less child in general, out of 18. Okay, so that's without replacement. All right, but the rules are still the same. You see the word and, you're going to multiply. So if you multiply across the top, you're going to get 336. If you multiply across the bottom, you're going to get 6840, which it's hard to compare. So change this into a decimal. You get approximately 0.05 or 5%. So the probability that all 3 were boys is a 5% chance. Okay? All right, so I'm sure you're thinking, when am I really going to use probability in real life? Well, according to this lesson, they use it in engineering, decision making. Who would have thought? All right, so let's take a look at example 4. All right, so it says, say that a power generating facility has 3 primary safety switches in case of an emergency. The probability that any one of these switches would fail is 5%. They want to know, in the worst case scenario, what is the probability that all 3 will fail given the switches are independent of each other? So you're looking at them separately. So we got to figure out what is the probability in like the worst case that switch 1 fails and switch 2 fails and switch 3 fails. All right, well, the probability that switch 1 fails, 0.05%, or not 5%, so 0.05, times the second switch failing, again, 5%, 0.05. Third switch failing, 0.05. So what's the probability that all 3 are gonna not work for you? If you multiply this out, you get 0.000125. So the probability that this would happen, you move it 2 places, is 0.0125%. So that's a pretty small number that all 3 switches would fail. So you just take their probabilities, multiply them out. Okay? All right, last problem of the year. All right, sometimes we have a two-way frequency chart. Okay, and sometimes we have to combine both those ideas of and or to figure out a total probability here. All right, so here's what we've got. We've got a chart, right? We have a company was determining the effectiveness of its warranty sales on computers. So, you know, you walk into Best Buy, you buy a computer, and then they go, oh, do you want the extended warranty? And then that tacks on a bill. So they just want to know. They're looking to examine the numbers. They took data on the number of customers who purchased warranties on 2 different brands of computers. Now, they want to know if a customer was chosen at random, what's the probability that they didn't purchase a warranty? All right, so we have 2 types of computers. So we have 2 separate calculations right off the bat, okay, to see if they purchased or if they didn't purchase a warranty. So let's kind of write it out in words to make it make more sense, right? We're interested in buying a computer and not buying the warranty. So we can have first the case of the probability that you bought type 1 computer and no warranty. So that's one of the cases, right? You bought type 1, you didn't get a warranty. The other scenario is the probability that you purchased type 2 and no warranty. So we got to get these numbers out. All right. The probability that you bought type 1. All right, 68% bought type 1. I'm going to change that to a decimal. So that's 0.68. We have and, so we know we're going to multiply. Now, no warranty. You got to be really careful. The percent who purchased the warranty, 35%. So if 35% purchased it, 65% didn't purchase it. So no warranty would be 65%. So when you do the math here, typing it into your calculator, you get 0.442. Okay, so that's the probability of buying type 1 and no warranty. All right, type 2 and no warranty. Type 2, 32%. Bought it. And they said 56% bought that warranty. Okay, so no warranty would be 44% or 0.44. So that's going to give you, when you type it into your calculator, 0.1408. Okay, so now to figure out the probability that they didn't purchase a warranty, regardless if it was type 1 or type 2, you have to add those probabilities together, because we look at either type 1 and no warranty or type 2 and no warranty, 2 separate probabilities. So you take your number 1, right, 0.442, and you add to it 0.1408, and you're going to wind up with 0.58 58.28, which means 58.28%, regardless of what computer they purchased, didn't buy a warranty. Okay? So that's the scoop here. So what I really want you to get out of this lesson is that when you see the word and, you multiply the probabilities. When you see the word or, you add the probabilities. Okay? And that's about it. So congratulations, we made it. You have one last Castle Learning assignment, and then you are done for the year. Enjoy your summer. Hopefully we're back in September. You come visit, we can chat. Maybe there's a chance we will see each other again for a second year, hopefully a full year. All right, enjoy your summer. Take care. It's been a pleasure getting to know all of you. Bye.